So we have an interesting product problem. So what it says that if it is given that the difference of two numbers is 12. So you have two numbers, the difference is 12. And then asking show that the product of these numbers has a minimum value. So if you want to find whether the what will happen to the product, and you can see that this product has a minimum. There's a minimum product. Asking show that there's a minimum product. We normally use those second derivative test or the first derivative test to show that there's a minimum. And then ask him find that product, whatever that minimum product, so find it. And then it says that can there be a minimum product for the two numbers? Actually, can there be a maximum product for the two numbers? So if there's a minimum product, whether there can be a maximum product. And also in the next one is asking if the two numbers need to be positive, if the two numbers needs to be positive, what would be the answer to the part B? So asking if the two numbers are positive, can there be a minimum in this case? It's a very interesting problem. So let's do one by one. So let's go to the first part. So show that the product of these numbers has a minimum value. So what we're going to do first is we're going to set up the problem. So how we start? We're going to start saying that, so let's say let x and y be the two numbers. So let x and y be the two numbers, and there are no any other conditions. It can be positive, negative, anything. And then the first condition says that the difference of these two numbers is 12. So let's assume x is bigger. So since the difference is 12, so you can say since the difference is 12, so you can write x minus y equal 12. So we assume x is bigger. So we assume x is bigger than y. Okay, so that's the first one. That's the constraint. Now let's try to write the objective function. So so then the product, we're gonna say p. Let's say p product is xy. So you can see that this is a two variable function. So what we normally do is we're going to solve for y and substitute for this one. So if you solve for y, what will happen? So you can see that this equation, if you solve for y, you can see that the y equal x minus 12. So that's what you get. So y equal x minus 12, and then we can plug in here. So this is x, x minus 12. So if you simplify, you get this one as x squared minus 12x. So that's what you get as the objective function. Now the goal is to check, show that there is a minimum for this problem. So there are like several ways to do that, and then if you look at the graph of this function, and you can see, so look at the, it's a parabola. So it's a parabola, and then you can see that there are two zeros. There's a 1 0 at 0, and the other 0 is at 12. That means if you look at the graph, you're going to get something like this. So you can see that that's a graph, and you can see this is 0 and 12. So you can see that there is a minimum. So that's like one way to do that. And it should be happen at 6 actually. So, but let's use like a calculus argument. What we can do for that, we can look at the second derivative. So, consider the second derivative. Okay, consider the second derivative. So let's look at second. First derivative is, you can see 2x minus 12, and if you look at the second derivative, and you can see that it is 2, which is positive. That means by the second derivative test, and you can see that since it's positive, has a minimum. So the second derivative test that this problem should have a minimum. So that's the problem that we're trying to do. Okay, so let's try to find that minimum. So the part B is asking find the minimum. Find the minimum product mentioned in part A. So let's do that. We already know that the product function, which is one variable function, which was x squared minus 12 x. So to find the minimum, what we do using the calculus argument, we look at the derivative. So it is p prime x, which is equal to x minus 12. Now what we can do, we can set this equal to 0 for the critical point. And then it says that when you set it to 0, you can see that 2x equal 12, so that x equals 6. So that is the critical point. So get the critical point. and then we already know that there's a minimum here, and otherwise you can look at the second derivative, so we don't need that step now. So what we can do is we can plug in this value to the function, because we already know that it has a minimum at so has a minimum at x equals 6. We already know that from the previous part, so that means we can find the minimum and just plug in the value out of the function. So at x equals 6, so you're going to get p6, which is equal to 6 squared minus 12 times 6. So what do you get actually? You're going to get negative 36. So negative 36 is the minimum value. So we can write it now. So the minimum is negative 36 when x equals 6. And what is the y value? So you can see the corresponding y value. So let's try to find it. So you can see when x equals 6, y equal, what do you get is, you can see it is x minus 12, that's the y value, so which is 6 minus 12, which is negative 6. So the y corresponding y is negative 6. So let's write the final answer now. So we can say the minimum is negative 36 when x equals 6 and y equal negative 6. So let's write it. So Manisha get negative 36 as the minimum product when, you can say, when the two numbers are, when the two numbers are 6 and negative 6. You cannot leave x and y in the final answer because x and y you introduce, so you can leave that in the answer. So this is how we write the answer for that one. So let's go to the next part. So in part C is asking, can there be a maximum product for the two numbers? We know that there's a minimum product, but can there be a maximum product? So how you can, from the graph, like it's clear that there's no maximum product, but how we can prove something like that using calculus? So that's the kind of idea here. So let's try to look at the problem. We can say, so the answer is no, so there cannot be a maximum product. So we can say notice that, so let's look at a situation like, let's say you're going to pick 22 minus 10. So what you do is you're going to pick a number and you're going to add 12. That's how we do. You can pick a number and add 12. So then what will happen? You can see the difference is 12 very clearly, and the product. So what's the product when you do that? And you can see in this case the product is 220. Okay, so you get the product in this case as 220. Now do the same thing. Let's pick like 100, and then what you can do is you can add 12. So it is 112, and you can see again the difference is 12. Difference is 12, and so the difference of these two numbers is 12, and you can see now the new product is so you can see 1/1200. So that's what you get. So you can see this number can be like infinitely large. So now how you can write this in mathematics? So that's the problem. So you can like clearly see that that's going. So how we can, this is how we can write it. So you can say for any x positive, so you can pick a x positive, and we can see select, you can say select y as x plus 12. So you can always do that. For any x, you can always do that. Then what will happen? Then you can see the difference y minus x equal 12. So you see that the difference is 12, and you can also see that the product, if you look at the product, which is xy, so which is simply x times x plus 12, and you can see clearly if you pick large x, this can be really large. Okay, so you can, and then you can say can be arbitrarily large, can be arbitrarily, that's how we write it, arbitrarily large, can be arbitrarily large. So that means there is no maximum product. This can be arbitrarily large. It's also very clear from the graph. So let's look at the next one. So in part D, it's asking if the two numbers need to be positive. Oh, this is like interesting problem. It says that the two numbers has to be positive, not like any numbers. So we have two numbers, but those two numbers has to be positive. So if the two numbers has to be positive, then can there be a minimum? if the two numbers has to be positive, then can there be a minimum? So that means you cannot pick 0 or like any negative numbers here, so that you can't get stuck here. So that means so there's no actually minimum value here you cannot pick, because there's no like if you say positive numbers, there's no any minimum for that. It can be any smaller and smaller, because you can see you can start with like 0.1, 0.01, 0.001. So you can see these numbers getting smaller and smaller, but there's no minimum. Okay, so no minimum. So that's create a problem. So then how are we gonna write this one? So you can see let's write it like that. So you can see there is no such a minimum. There is no such a minimum. There is no such a minimum. Now how to write it? So we can say notice that. So let's look at some numbers. Like for example, notice that 0.1 times 12.01, because what you do is you pick a number and then so you're gonna pick 12, and then what you do is you're gonna yeah, so this number is not exactly correct, it should be 0.1. So you can see what you're gonna do is you pick 0.1 and then just add the same number to the other side. So that we can do, and then when you do that, you can see the difference is 12, and the product, so if you look at this one, so you can see this is actually 1.12, so you're going to get 1.21. That's what you get. And then how about 0.01 times 12.01? So you add the same number into both places. So then you will see that this you're going to get 0.1201. That's what you get. So that means in general, so you can see in general, yeah, in general you're going to pick n, like 1 over n, and then also we're going to add the same number. So it's 12 plus 1 over n. That's what we do. And when you do that, you can see this is 1 over n times 12 plus 1 over n, and you can see this can be arbitrarily small. Okay, so can be arbitrarily small. Can be arbitrarily small for a large n. So because of that, since this simply goes to 0, that's why it says this simply goes to 0 when you pick larger and larger n. So that means there is no minimum value if the numbers are positive. If the numbers need to be positive, you can see that there's no minimum value. Very interesting problem.